So we got our house model into a digital twin. Now that's a great first step, but now our data has changed. So it's important that we talk about that. We started with this DGN file, and now it's been ported over to this cloud-ready format, which we call an iModel. First off, why do we even change the data? Why did we convert our house DGN into this iModel? The reason for that is our digital twin is not just limited to the house model or even DGN files. The iModel was designed to be an open format that can collect data from any engineering format. So far, we have connectors for Revit, IFC, Civil 3D, just to name a few, and there are many more to come in the future. So we could potentially push a roadway that was made in Civil 3D and a building that was made in Revit, in addition to the house model, in the same digital twin. Now that's where the problem comes in. All these data sources come with their own schemas and complexities, and we're going to require specialized knowledge to query any data from them. When you think about writing an application that consumes these data sets, this creates a massive learning curve. And that's just a bummer. Where do you even start? Lucky for us, BIS comes in to save the day. BIS stands for Base Infrastructure Schemas. What it does is it defines a set of base classes that capture the core commonality behind all these different data sources, the house, the building, and the road, and also defines specialized classes to capture data that pertains to a specific data source, such as the smart devices in our house. I'll give an example of both. Let's consider the roadway and the house in our digital twin as an example. Now, there are two types of properties both these models can have. Properties that are common to both of them, or properties that are not, that are more specialized to each data set. Which ones are common? The most obvious one is 3D geometry. Any 3D model is going to have 3D geometry. The house has the shape of its walls, the road has its curvature. BIS gives us a common format to represent this 3D geometry property. Another example of a common property is a description or label. Different elements throughout the road or the house are going to have labels to identify them. And then there are properties that are not common between the two models. The house, for example, has its unique smart device IDs that we saw in the DGN. The road may have, let's say, mile markers. BIS provides classes for these specialized properties as well. And these specialized classes are built on top of the base classes, so our data is organized in an efficient and tight manner. In this way, BIS enables us to create applications that can understand the common data between all formats and also more specialized data of each individual format. It gives us an easy way to start writing queries for these disparate data sources. And that's exactly why BIS is such an essential part of the iTwin platform. Now, I know this is a lot of theory, so let's go ahead and put this knowledge into practice. We'll search through our house data to find our smart device IDs, and we'll also look at the tools we have for understanding and exploring BIS schemas and writing queries against iModels.